So I want to go over this answer key or this answers to this relative mass in the mole. I'm not going to go over everything, but I do want to go over and point out a couple things. The first part here is just an analogy that they're using. So uh, in when we talk about number of eggs, right? We don't usually talk about one egg, two eggs. We talk about dozens of eggs. So we use this term dozens, right? Uh, because we buy eggs by the dozen. We don't buy a single egg or two eggs. We buy a dozen eggs, 12. Okay. Uh, when we talk about atoms and molecules, we don't really talk about one atom or one molecule. We talk about a mole of them. Okay, a mole is just a number of them. And the reason for that is just because an atom is so small, a molecule is so small that we need a lot of them to make any significant, like, real world impact, right? Uh, so I'm not even going to go over the answers to this part here. They're all given to you here. Hopefully you understood that. Uh, I'm going to move right on to the part where we talk about atoms and the mole. Okay, so let me just talk about this, read this real quick. So again, like I said, uh, we're going to be using, when we look at atoms and molecules, uh, we're going to be using a mole. All right. Now, let's see here. Let's see. What do I want to talk about here? So I'm going to skip all this actually. Just make sure you do it. Make sure you do it carefully and you pay attention to it. I just really want to talk about this. This is really all I want to talk about. Molar mass. What is molar mass? Okay. Molar mass, basically, if you have one atom of hydrogen, it's 1.01 AMU, or atomic mass units. Okay. If we have a mole of hydrogen atoms, it's 1.01 grams. So basically, what scientists said was, if we have one atom of hydrogen, how much does it weigh? Okay. Now, if we want to convert that to grams, which we can weigh, so we can't weigh an atomic mass unit. We can't weigh one AMU on a scale. Okay. But what if we want to weigh hydrogen on a scale? Well, we need to convert that AMU to grams because usually we use grams. So what number is that? How many hydrogen atoms would we need? And that number is 1 mole. If we have 1 mole of it, we can convert moles to grams. Okay, and the unit for, or the where to find that on the periodic table, it's always on the bottom here, and it's always an like a decimal. It's not always a decimal, but it's usually a decimal. That's because it's actually an average of all the isotopes of that element. So we talked about isotopes a little bit earlier in the year. Each one of these atoms has different isotopes. So when we take an average of their mass, uh, the isotopes create um, this decimal here. All right, it's just kind of a weighted average. So remember, we did weighted average before when we talked about isotopes, and that's why it's a decimal here. All right. So if we want to find the molar mass of a compound, as we did here for like iron 2 sulfate, iron, we take the mass of iron plus the mass of sulfur plus the mass of 4 oxygens. Okay, and we do that by looking at the periodic table. Um, so iron here is 55.845. Sulfur is 32.066. And oxygen is 16, or 15.999, and we have 4 of them. Sorry, 15.99. So if we do all that, we should get this 151.9 AMU. Okay, so that would be the molar mass of this compound. So if we had a mole of this compound, it would weigh 151.9 grams. Okay, it would be 151.9 grams. If we had one molecule of it, it'd weigh 151.9 AMU. Okay, again, when we have a mole of something, it's just converting the AMU to grams. Okay, how much is a mole? Well, this is a mole right here. 1 mole is 6.02 times 10 to the 23rd particles. It's a really, really big number. Okay, it's a huge number. It's, yeah, more than you can count in your lifetime. If you took tiny green peas, one of the analogies is if you took tiny green peas and you got a mole of them, I think they would cover the entire United States by like 5 miles or something like that. It's something ridiculous. It's a giant number. It's huge. It's a huge number. Okay. The last part, the answers weren't given to you here, so let's do this together. So fluorine gas consists of a diatomic molecule F2. How many molecules of fluorine are in 1 mole of fluorine? It's always the same. Anytime you ask for how much is in 1 mole, it's 6.02 times 10 to the 23rd molecules for 1 mole. Okay, what is the mass of 1 mole of fluorine gas? So careful, because fluorine gas, again, is a diatomic. So there's 2 of them. I'm just going to round it to 19. So that's 18.998, but I'm going to round it to 19. Oops. Where did you go here? Okay. So 19. Now, but that's for 1. That's for 1 fluorine. And remember, it's diatomic. So it's 19 grams per mole times 2. 38 grams per mole for F2. How many atoms of fluorine are in the sample? So if we want to know how many atoms of fluorine, so there's 2 atoms of fluorine for every 1 molecule of F2. So we got to multiply that. So we get 2 atoms of F. Okay, the mass of 1 lead atom is 207.2 grams. Use a proportion to calculate the number of lead atoms in a 15-gram sample of lead. I don't really like this question because we're not going to be doing it this way. So, I mean, I'll do it, but so 207.2 grams for every 6.02 times 10 to the 23rd atoms, because it's that many atoms in 1 mole. And that's equal to 15 grams over X atoms. So cross multiply 15 times 6.02 times the 23rd equals 207.2 times X, and divide by 207.2, divide by 207.2. So whatever you get there, I'm not even going to do the calculation. Okay, what is the mathematical relationship between atomic mass units and grams? So 1 gram equals how many AMU? Well, 1 gram equals 1 AMU over 6.02 times 10 to the 23rd, right? Because there's 6.02 times 10 to the 23rd AMU in 1 gram, so it's just a reciprocal of that. All right. Hopefully that helped a little bit. I'm going to make another video. Really, the most important video is going to be on the next topic, or the next worksheet, which is calculating molar mass and then converting units. So really pay attention to that one.